Hi, third graders. This next bit is activity 2 for lesson 9, and it's all about fast arrays. So I'm going to teach you how to make a fast array, what a fast array is, and how to use it to help you solve problems that are dealing with arrays. So you're going to love them. They're really awesome. I think I accidentally gave you sneak peeks about fast arrays before, but we're going to really learn about them now. So first thing I wanted to talk to you about is, what are we talking about? We're talking about a fast array. A fast array is exactly what it sounds like. It's another type of math drawing, like equal groups or equal shares or a regular array drawing, but it's way faster. So we just had a problem where I drew out 27 whole dots in an array for our students who were in the orchestra, and that's fine. That's totally a way to draw it out if I draw my full array. But it takes a long time when I already knew what I was talking about. It feels a little silly to spend that much time just representing the problem in a drawing. So I'm going to teach you how to do a fast array. There are two types. One type is if I know my rows and my columns. If I know my rows and my columns, you're going to see the dots forming a shape on the outsides, okay? So for example, if I say Mrs. Scholes has a class full of students, they are organized into 6 rows of 5. How many students does she have? Well, she has 6 rows of 5. We know that would be 6 rows of 5, or a 6 by 5 array. So you would draw it exactly like that. 1, 2, 3, 4, 5, 6. There's my 6 rows by my 5 in each row. 1, 2, 3, 4, 5. Always remember to count this as 1 so that you don't end up with an extra one. So I double check. I have 1, 2, 3, 4, 5, 6, or a 6 by 1, 2, 3, 4, 5. Bingo. Now instead of filling in all of those dots, what I'm going to do is I'm just going to solve it and put the answer in an answer box in the middle. Sound good? I know 6 times 5. That's a fast fact for me already because I've been practicing my 5s. But you can also count by 5, so we'll go ahead and do that really quickly here. I'll count by my 5s 6 times. 5, 10, 15, 20, 25, 30. It's so much easier for me to say there's 30 students by writing the number 30 than it is for me to draw out 30 dots. So that is example 1 of a fast array. And that's when I know my rows and columns. Okay, that's the first way. That way is really, really common. The second way is if I know my total and either my rows or my columns. So one of these sides, I don't know. It's my unknown. But I do know the total. So for these ones, I know the total. Plus one side. For example, I could say Miss Ron Hoppy has 30 students. She puts them into 5 groups. How many students are in each group? Well, if I know that I start with 30 and I'm putting them into 5 groups, man, that's gotta be a number that's shrinking down, right? I'm gonna shut off this middle row of light, so hopefully the glare is not so bad. Give me 1 second, okay? There we go, that helped us a little bit. So, I know that I started with a big number 30, and I'm splitting them into 5 groups. So it's gonna be a division problem instead. That means that for my fast array, I know that inside number to start with. So I'm going to go ahead and label it to start with. And then, oh my goodness, my friends, I should have said I put them in 5 rows. My bad. Instead of groups, they're in rows. So I'm going to say, okay, 5 rows. Let's make 5 rows. 1, 2, 3, 4, 5. But I don't know how many are in each row. That is what I'm trying to find. That means that I knew the one side, I knew how many rows, but I didn't know how many were in each row. That's my unknown. And the first one, my unknown was the total. This one, my unknown is how many are in each row. We can solve it the same, 30 divided by 5, so we would count by 5s again, because we start with a small number and count up, and I know there's going to end up with 6 in each row, okay? If that didn't quite make sense for you, then you can peek more. It's on that second page in your activity packet. It's actually page 44 in your packet. And we're going to do 2 practice problems together, and then I will be checking on your math homework to see how that goes for you today. So, go ahead and erase. And I'm going to have you check out my problems for fast array practice. Here's the first one. Beth planted tulip bulbs in an array with 9 rows and 6 columns. How many bulbs did she plant? Well, if we know our rows and we know our columns, we can do a side-by-side array. Yeah? So we can make 9 rows and 6 columns. Let's draw a 9 by 6 array. 1, 2, 3, 4, 5, 6, 7, 8, 9 by 6. 1, 2, 3, 4, 5, 6. And that 9 by 6 array will give me my answer. So before I continue, I did kind of speed through reading that. I only read it the one time, and I know that the best mathematicians read it many times. So let's read it at least one more time together. And I want you thinking about what would be some special information that I still need to mark up to know what I need to put for my equation with a variable. So, read with me. Beth planted tulip bulbs in an array with 9 rows and 6 columns. How many bulbs did she plant? Did you catch the key information? How many bulbs, right? So, we're talking about bulbs, which means my equation gets to be about bulbs. And I'll switch to my darker marker here. If it's a 9 by 6 array, certainly I get to do 9 times 6 equals B for bulbs. B equals what? Let's go ahead and use our 9s trick. So I would count over 1, 2, 3, 4, 5, 6 fingers, which means that 9 times 6 is 54. B equals 54 bulbs. 54 would have been my big number in my drawing, and that's how I can solve that. Please erase. I'm going to put up another one here for you. The 36 students in the chorus stood in 4 rows for their school picture. So I have 36 total students. They are in 4 rows. How many students were in each row? This is our other type of fast array. If I know my total number of students is 36, I put my total inside. There are 4 rows, so I line up my rows. You are finding the unknown. So if you are finding that unknown there, you can do a couple things. First, you could count by fours up to 36. We don't know our fours super well, so we probably don't want to do that. You could also just use your fours, count bys and list them. So 4, 5, 6, 7, 8. And you might go ahead and keep doing that. 9, 10, 11, 12. 13, 14, 15, 16. 17, 18, 19, 20. 21, 22, 23, 24. 25, 26, 27, 28. 29, 30, 31, 32. 33, 34, 35, 36. And I get a stop because I got to my total. So, this is the part where I'm checking in with you. I am checking, what would your equation look like? This will be the practice problem that I put on your slides to see if you know how to write your equation to match this problem, which was right there. And I want that variable in there also, please. Solve for this one, how many students were in each row, and I will put it on the Google Slides. And then you'll go ahead and move on to homework and remembering. So, good luck today, friends.